Hello, Coach Travis here with another calculus video. So what we got here is a definite integral, a very scary looking definite integral. But they're really nice to you on this problem because they draw the graph for you. Wow, that is really nice. So, I might not be so nice, on an exam or something. I might not give you this picture. Now, of course, you're free to use GeoGebra on your exam. So if I didn't give you this picture, then you would be free to use GeoGebra to draw the picture. But it is very nice of the problem to draw the picture for us. So, okay, so the idea here is that, so definite integrals can seem really intimidating and hard because of their definition. The definition of a definite integral is the limit of a Riemann sum, and that is a very difficult thing. However, at the end of the day, what the definite integral turns out to be is it turns out to be the signed area under the curve. So in a case like this, where everything is straight, then evaluating a definite integral is kind of easy, because it's just what's the area, or technically what's the signed area. So basically, if I think about what this question is asking, if I were to visualize what this question is asking, all it's asking for is, it's saying that x is going between -5 and -3. Okay, so here's -5 and here's -3, and it wants the area under the curve and above the x-axis. So basically, all this question is asking for is what is this area? What is the area of this? And it's a since everything involved is a straight line, this is just a triangle. So all this question is basically asking for is what's the area of this triangle? And that's actually super easy, because we know that a triangle has area 1/2 base times height. So the base of this triangle you can see is 2, and the height of this triangle is 1. So the answer to this question is simply the number 1. So the moral of this story is definite integrals can be hard. Okay, so I don't want to give you the impression that definite integrals are easy. Definite integrals can be very hard, but the reason they're hard is when you're dealing with something curvy. If you're dealing with something that's curvy, then finding these areas is very difficult. But if you're dealing with something that's straight, then finding the area is a piece of cake. So when you are confronted with a scary looking definite integral, the first thing you should do is draw a picture. Because if it turns out to be something with a bunch of straight lines, then the definite integral is actually usually pretty easy to figure out. Whereas if it has some curvy lines in it, then you're in trouble. But we'll worry about that a little bit later. All right, so speaking of curvy things, you might say, uh-oh, here's a curvy thing. So we got a definite integral here. And so remember, a definite integral, the technical definition, it's the limit of a Riemann sum as the number of rectangles goes to infinity. But the practical definition is that it's the signed area under the curve. So if I'm going to draw, let's draw a picture of what this integral should be equal to. So it says start with x is equal to 2. Okay, so x is equal to 2 is right there. And then end at x is equal to 4. Okay, x equals 4 is right there. And so a picture is it's going to be the area of this region right here. There we go. That's a decent shading there. And so the bad news is that it's curvy, and so that's kind of scary. But the good news is that, well, not all curves are beyond our understanding. In particular, this is a circle. If you do the algebra, you can recognize that this is the equation for a semicircle. So this actually is a circle, or a semicircle. This is a semicircle, and so that means that this area, this little shaded region there, it looks like it's a quarter. If this is half of a semicircle, okay, so half of a semicircle is a quarter of the entire circle. And this is a circle with radius 2. And so the entire circle would have area pi times 2 squared. So a quarter of the circle is going to have is going to have 1/4 times pi times 2 squared. And that, of course, the 4's cancel there. So this one just turns out to be pi. That integral, it looks really scary, but it turns out this integral is equal to pi. And the way we figured it out is we just drew a picture. So again, what's the moral here? The moral here is if you see a scary looking definite integral, your first instinct should be to draw a picture. Use GeoGebra and draw a graph of the function and see, hey, do I recognize that? Does it have straight lines in it? And then I could find the area just using triangles. But if it doesn't have straight lines in it, maybe the curves are something that you recognize. Like in this case, you say, oh, well, it's not straight lines, but it is a semicircle. And once I see it's a semicircle, I can just use geometry to find the area.